A very good morning to all our viewers. I, Kriti Vadhera, welcome you to CIET NCERT's live phone-in program. And today, we would like to congratulate all 12th class students who have come out with flying colors in their results. Congratulations to you once again. And we'll be discussing 10th class mathematics topic in this live interaction today. And to join us on this topic, I have expert Professor V.S. Prasad sir. Sir, we welcome you. Good morning, sir.
Thank you, madam. Good morning, everybody.
And the topic which sir would be taking today, it's going to be chapter 7, the coordinate geometry. So let us start, sir.
Okay, madam. No problem. You have any explanations regarding your phone numbers, other thing?
Yes, of course, because it is a live interaction session and
Yes,
our
please.
viewers can ask questions to sir on this our toll-free numbers. You can dial us on 1800111265 and the other number is 1800112199, and you can also ask questions, sir, on our email address. The email address is ciet.kishoremanch@gmail.com, and you can also watch the live streaming of this program on YouTube on our official YouTube channel NCERT Official. So we shall start, sir.
Yes, madam. Thank you very much. Good morning, students. So today we are going to see chapter 7, coordinate geometry. This is the first part of this particular topic. Before going to see what are the things we are going to see, let us have a major concept list. We start with the introduction to the coordinate geometry. Then we are going to prove one very important result called distance formula and applications and problems on distance formula. Finally, we will see the formula for section formula and its special cases. Before going to see this distance formula, let us see how this coordinate geometry actually helps us in our daily study. In fact, this coordinate geometry is actually, we call it as an algebraic tool for studying geometry of figures. And also it helps us to study geometry using algebra. In other words, to understand algebra with the help of geometry, we need one important tool which we call it as coordinate geometry. So because of this reason, this coordinate geometry is widely applied in various fields such as physics, engineering, navigation, etc. So now we have already seen in our earlier classes how to locate the position of a point using a pair of coordinate axes which are perpendicular to each other. This you have studied already in class 8 and 9. In fact, the distance of the point from the y-axis, we call that as x coordinate, which is also another important word we are using as abscissa. In fact, abscissa is a word borrowed from New Latin, which is a short form of the word linea abscissa, which means cut off lines. Its first known use was way back in 1694. And also the distance of a point from the x-axis, we call it as a y-coordinate or also called as ordinate. In short, the distance along the y-axis is called ordinate and the distance along the x-axis is called abscissa. In fact, here we are using two words. One is coordinate and ordinate. That's why it is better to understand the difference between these two terms. That is coordinate and ordinate. The term coordinate is actually represent the position of the point along the line or and so on. Whereas the term ordinate represent the value of the coordinate on the y-axis. So it should be very clear. Ordinate means value of the y-coordinate and coordinate means it is a value of position of the point on the plane. So in short, if x comma y indicates the position of a point in a plane, then if you write it as a pair x comma y, x indicates abscissa and y indicates ordinate. And in fact, graphically it is denoted as follows. Look at the figure. Whenever we take a point in a plane, we denote it as p of x comma y. The length OC we call it as x distance, which we call it as abscissa, and the length BC we call it as ordinate, which is called as y coordinate. And of course, if you observe carefully, the coordinates of the point on the x-axis where there is no y present, easily we can represent it as x comma 0, and of the point on the y-axis easily represented as, because there is no x length is there, it can be denoted as 0 comma y. So with these background, now we are going to see how to identify the distance between any two points in a given plane by using a formula called distance formula. Here, depending upon the position of the points, we are going to identify different cases. It will be helpful for our students. That's why we will discuss all these things case by case. First case I am going to take distance between 2 points on the y-axis. If both the points are lying on the y-axis, then how to identify the distance? It is given by the difference between their ordinates. Note that length is always positive. Whenever we are taking the differences, we have to take care that the value should be always positive. That's the thing we have to take. Let us observe this. Let A comma B are 2 points on y-axis given as follows. So in the figure easily you can understand, A denotes on the y coordinate which has the coordinate 0 comma 5, and B denotes the point below which has the coordinates 0 comma minus 3. Then clearly A is equal to 0 comma 5 and B is equal to 0 comma 3 minus 3. Therefore the distance AB is given by difference between their ordinates. Therefore 5 minus of minus 3, that means 5 plus 3, that becomes 8 units. So the distance between the point A and B denoted as 8 units. In this way we can identify when the points lying on the y-axis. Let us see one more example. Suppose C is a point with the coordinate 0 comma 17 and D is a point with the coordinate 0 comma 1. Both are on the positive side. Then find the distance between them. So if you observe the coordinates 17 and 1 are there, are the ordinates. Therefore by the given condition the distance is denoting by CD, that is equal to 17 minus 1, that is equal to 16 units. Similarly, take one more example. Let x is equal to 0 comma minus 13 and y is equal to 0 comma minus 5. Note that both the points are lying below the x-axis, down actually on the negative side. In that case, the solution is difference between their ordinates. Therefore, I am going to take the first one is actually minus 5, minus of minus 13. That becomes minus 5 plus 13, which is nothing but 8 units. Note that distance is always positive. In that way, we have to take. So in this way, we can identify the distance between 2 points when they are lying on the y-axis. Now we are going to see case 2. Here, if the 2 given points are lying on the x-axis, in that case, we define the distance between them as the difference between their abscissa. That's the definition we are going to take. For example, let us take P and Q are 2 points given on the x-axis as follows. Easily you can observe on the graph sheet, x on the x-axis, P is a point with the coordinate 7 comma 0. Here the abscissa, that means the x coordinate length is 7, and another point is Q is minus 2 comma 0. Here its abscissa or x coordinate is minus 2. By identifying these 2 coordinates, we will define the distance between these 2 points as PQ is equal to the abscissa of P is 7 and the abscissa of Q is minus 2. Therefore 7 minus of minus 2, that becomes 7 plus 2, that is 9 units. Therefore the distance between P and Q is exactly equal to 9 units. Like that we have to identify the distance. Let us take one more point. If S is a point with the coordinate 20 comma 0 and T is a point with the coordinate 9 comma 0, note that both the points are on the positive side of x-axis. Then the distance between them is difference between their abscissa. Again note that we have to take the bigger number as the first one and smaller number of the second one to find the difference. Therefore ST is equal to 20 minus 9, that is equal to 11 units. One more example we will take. Let M is equal to minus 5 comma 0 and N is equal to minus 11 comma 0. Note that here both the points are lying on the negative side of x-axis. So in that case the distance between them is Mn is equal to, now I am taking minus 5 first, then minus of minus 11, that becomes plus 11. So minus 5 plus 11 is actually equal to 6. Therefore the distance between M and N is given by 6 units. Just for the practice for our students, I am giving certain points. Find the distance between the following points. A 0 comma 1, B 0 comma 9. Next A 0 comma 7 and B 0 comma minus 8. Next P 3 comma 0, Q 8 comma 0 and P minus 6 comma 0 and Q minus 19 comma 0. Note that all the points either they are lying on the x-axis or lying on the y-axis. By observing the previous 2 cases, In fact, I have given the answers also. You please check it and verify it whether the answers are correct or not actually. In this way, we can find the distance between any two points which are lying on either x-axis or y-axis. Now the question is, other than these two situations, suppose one point is on x-axis and another point on the y-axis. This is the case 3 now we are going to see. If the given one point is on x-axis and the other point is on y-axis, then the distance between them can be found by using Pythagoras theorem. Let us see this by taking the following example. I hope you all know what you mean by Pythagoras theorem. That is nothing but in a right angle triangle, Pythagoras theorem says that the square of the hypotenuse means you can understand by joining those points AC, the square of the hypotenuse is always equal to the sum of the squares of the lengths of the other two sides. This is Pythagoras theorem. We already proved in the last class also. Now by using this result, we will identify the length between 2 points where one point lying on the one axis x-axis and another point is lying on y-axis. Let us see how it looks like by taking the following example. Let us take point P is equal to 12, 0. Note that this point is lying on the x-axis and Q is equal to 0, 5. Note that this point is lying on the y-axis and they are the points on x and y-axis respectively. Now to identify the distance, what you have to do is, let us join P and Q. We will get a line PQ such that we will get a triangle POQ, and you can easily see that it must be a right angle triangle as shown below. So if you observe this right angle triangle, by given the coordinates of the points, we can easily see that the length OP along the x-axis is actually gives us 12 units and the length OQ along the y-axis is given as 5 units. Now our duty is to find the length PQ actually. Now clearly it is a case for applying the Pythagoras theorem, just only to find the length of the hypotenuse. For that we are applying Pythagoras theorem as follows. So by applying Pythagoras theorem, we know that PQ square, that is PQ square is the hypotenuse, is equal to OP square plus OQ square. OP square is along the x-axis and OQ square is along the y-axis. So by Pythagoras theorem, PQ square is equal to OP square plus OQ square. OP is given as 12, therefore it becomes 12 square plus 5 square. 12 square means 144 and 5 square means 25. The sum of them is actually equal to 169. So PQ square is equal to 169, and by taking the positive root, we will get PQ is equal to positive root of 169, and 169 root easily we can see that it is equal to 13 units. Therefore, the distance between P and Q, that is nothing but PQ, is actually given as 13 units. So in this way, by applying Pythagoras theorem, we can find the distance very easily. Let us see some more problems. Similarly, our students can try to find the distance between the following points and by applying the Pythagoras theorem as it is. A 6, 0, it is a point lying on the x-axis. B 0, 8, it is a point lying on the y-axis. Second problem, P is equal to minus 9, 0 on the x-axis, Q 0, 5 on the y-axis, and yes, 3, 0 on the x-axis, T 0, minus 4 on the y-axis. And the very interesting thing is, when they identify these points on the graph sheet, let them draw the right angle triangle and what is the position of the right angle triangle, how it looks like, that they identified. Then through that they can find out the hypotenuse of that right angle triangle, which is nothing but the required distance between the given two points. Let them try and find out the answer. Now we are going to see case 4. Here, if P and Q are any 2 points on a given plane, then in that case we need to find the distance between them. Let P, I denote the coordinate of first point as x1, y1, and Q, second point as x2, y2. We took any 2 points up in the coordinate plane. Then the distance between them can be found by using again Pythagoras theorem as follows. This is the derivation of the original result, what we call it as distance formula. So let us identify the given points on the coordinate plane as follows. So look at the situation. I have 2 points, P of x1, y1 and Q of x2, y2 are any 2 general points I have taken on a plane. Now to derive the distance, here what we are going to do is, we are drawing lines parallel to given axis. For x-axis, I am drawing parallel two lines which passing through the point P and Q. For y-axis, again I am drawing two lines which are parallel to y-axis. By keeping this idea in our mind, now we will identify the corresponding right angle triangle on the plane, and which comes as follows. So by drawing the lines parallel to axis through P and Q, which meets a point, we identify that point as T. If you observe the T, it exactly looks like that is a point T actually, corner. Then we can see that triangle PTQ becomes a right angle triangle at the point T actually. So from the Pythagoras theorem, by observing that one, we can see that PQ square is equal to PT square plus QT square. Look at the figure. PQ square is equal to PT square and TQ square. T is actually missing in the figure, no problem. You just identify that as T actually. Okay. Now, PT square is actually difference between the ordinates because those two are the points again parallel we are taking. Therefore, we denote the distance as x2 minus x1. Therefore, PT square becomes x2 minus x1 whole square. And QT is corresponding point on the y-axis. Again, the difference between their ordinates. So it becomes y2 minus y1 whole square. Therefore, our PQ becomes the positive root of x2 minus x1 whole square plus y2 minus y1 whole square. This result, PQ is equal to positive root of x2 minus x1 whole square plus y2 minus y1 whole square. We call it as the official distance formula between any two points on a plane. Right. In fact, we can observe this formula holds true in all the four cases. It is a generalized situation. So in any cases, we can apply this formula. So therefore, in all the four cases, we can use this formula. And in particular, if you have one point as origin, another point is any point on the plane P of xy, then from the origin, the distance of that point being identified with that formula by taking the corresponding coordinates of the origin as 0, 0, we see that the formula can be simply written as OP is equal to the positive root of x square plus y square. So in this way, we can identify the distance between any 2 points on a given plane by observing different cases. Now let us see some interesting applications or some problems by using this particular distance formula, and we will see how it is useful to find those new things.
Sir, before you head on to the next problem, there are many viewers who are watching you live and students want to ask you. There's a very basic question. I have a viewer, Girisha Bhati, and she wants to ask you that, sir, is it compulsory to always take the large value first and then small value while subtraction?
Yeah, actually we are defining it as a difference between abscissa or difference between ordinates. Our interest is whenever we take the differences, there may be a chance to get negative number also, but distance cannot be negative. So to keep the distance as positive, just as a common sense, we are applying this idea to get the difference between bigger number and smaller number. That's the simple idea we have.
Right.
I hope they will.
I hope Grisha has got her answer right.
Yes. Shall I continue, madam?
Yes, sir. Absolutely.
Thank you, madam. Thank you. Okay. Let us see the first problem. It's a direct problem. Just for the beginning, I am going to take this as one simple problem. Find the distance between the points -5, 7 and -1, 3. Now, given points are, first point P, I am taking it as x1, y1 as -5, 7. That means our x1 first coordinate is -5 and y1 is 7. And Q, I am denoting it as x2, y2. That is nothing but -1, 3. That means x2 is -1 and y2 is 3. Now, simply by applying distance formula, that is PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Here, one important thing I would like to mention you. There is no compulsion that whether you have to take x2 minus x1 or x1 minus x2. Because when we are taking the difference, we are taking it as square. When you make a square, you know already that the square of any real number is always positive. That's why you have to remember that either you can take x2 minus x1 here, there is no problem, or you can take x1 minus x2 also, there is no problem. Similarly, either you can take y2 minus y1 or y1 minus y2, because their squares will have no change in the final answer. So by keeping that thing in your mind, By substituting the values of x1, y1, x2 and y2, we get square root of minus 1 minus of minus 5 whole square plus 3 minus 7 whole square. Here I am not putting any condition as we observed in the beginning, because we are checking the terms in terms of squares. That's why when we take the square, the value is always positive. That's why I don't have any problem. That is the clarity we have to observe. So first term becomes minus 1 plus 5, that is 4 square. Second one becomes 3 minus 7, that is minus 4. Minus 4 whole square I am taking. Here actually I am not taking the distances, I am just using the formula. That's why square is always positive. I have the full freedom to take in any direction without any confusion. That's the thing student should keep it in their mind. So 4 square is 16, minus 4 whole square is also 16. That becomes square root of 32. Now by observing its positive value, it becomes 16 into 2 we can write. 16 we can take it outside from the root. That becomes 4. Therefore the length PQ is actually equal to 4 root 2 units. Therefore the distance between the points minus 5 comma 7 and minus 1 comma 3 is actually 4 root 2 units. A general problem actually I want to take. Now we observe another problem. Actually here we are going to see the interesting applications of our distance formula. That is the first application I am going to identify. Problem is like this. Determine if the points A of 1 comma 1, B of minus 2 comma 7 and C 3 comma minus 3 are all collinear or not. I think in the earlier classes you know already mean by collinear. 3 points are said to be collinear means they must be laying on the same straight line actually. In fact, another condition for that is 3 points A, B, C are collinear if the sum of the lengths of any two line segments among AB, BC, CA must be equal to the length of the remaining line segment. That means either AB plus BC is equal to AC, or AC plus CB is equal to AB, or BA plus AC is equal to BC. Any one suitable things we can use it for the given points. Now look at the length of these line segments. AB, I am using those points coordinates of A and B. I will get the formula as square root of minus 2 minus 1 whole square plus 7 minus 1 whole square. That is nothing but root of minus 3 whole square plus 6 square. Minus 3 whole square is 9, 6 square is 36. 36 plus 9 is actually root 45. And 45 can be written as 9 into 5. 9 can be taken outside from the root, it becomes 3. Therefore, AB is denoted as 3 root 5 units. Now BC, by using the coordinates of B and coordinates of C, we look like 3 minus of minus, it becomes plus, therefore 3 plus 2 whole square plus minus 3 minus 7 whole square. 3 plus 2 whole square is 5, 5 square is 25, minus 3 minus 7 is minus 10, minus 10 whole square is actually equal to plus 100. Therefore 25 plus 100 is root 125. So 125 can be written as 25 into 5, and that 25 comes out from the root, it becomes 5. Therefore the length BC is actually 5 root 5 units. Then last length is AC. That is again by using the coordinates of A and coordinates of C, we can write it as square root of 3 minus 1 whole square plus minus 3 minus 1 whole square. So 3 minus 1 whole square is 2, 2 square is 4, and minus 3 minus 4 becomes minus 1 becomes minus 4, and minus 4 whole square is 16. Therefore 4 plus 16 is 20, root 20. So root 20 can be written as 4 into 5, and that 4 it comes out from the root, it becomes 2. Therefore AC becomes length as 2 root 5 units. Therefore look at the sum AB plus AC. AB is 3 root 5 and BC is 5 root 5 and AC is 2 root 5. So AB plus AC is 3 root 5 plus 2 root 5. I hope our students they know how to add two irrational numbers. Whenever we have two irrational numbers, by keeping the irrational part as it is, just by adding the remaining part apart, you will get 3 root 5 plus 2 root 5 is equal to 5 root 5. That is nothing but BC. Therefore AB plus BC is equal, AB plus AC is equal to BC means all the three lengths are coincides, means hence the given 3 points are collinear. In that way we can. If the any two sums are not equal to that one, then you can observe that the points are not collinear. In fact, I will give one exercise for students to check. These are the points I am giving. If the points 1 comma 5, 2 comma 3 and minus 2 comma minus 7, whether they are collinear or not, you have to check. Just as a hint I am going to give to you, they are not collinear. Why? That you have to check it by observing the corresponding distances. Okay. Now another interesting problem, which is also a wonderful application of our distance formula. Let us see this problem. Check whether 5 comma minus 2, 6 comma minus 4 and 7 comma minus 2 are the vertices of an isosceles triangle. I hope you all know what you mean by isosceles triangle. A triangle is said to be isosceles means any two sides must be equal. That's the condition. Okay. If all the three sides are equal, it becomes equilateral triangle. If two sides are equal, it becomes an isosceles triangle. So we know that an isosceles triangle, any two sides are equal. Now three given vertices of the point a triangle is given. A, I denote it as A 5 comma minus 2, B is equal to 6 comma 4 and C 7 comma minus 2. Then I am going to find the length of those sides of triangle given by AB. It is nothing but by taking the coordinates of A and B and applying distance formula, it comes as square root of 6 minus 5 whole square plus 4 minus of minus 2 whole square. Then that is nothing but 6 minus 5 is 1, 1 square is 1, 4 minus of minus 2 is plus 2, 4 plus 2 is 6, 6 square is 36, therefore 1 plus 36 is equal to 37, root 37 I got it. Therefore AB length is root 37. So next look at BC. Again by using the coordinates of B and the coordinates of C, apply the formula. Here don't worry about bigger or smaller because of the square, you are full free to apply whatever the coordinates you are. That's the thing you have to identify. It is equal to square root of 7 minus 6 whole square plus minus 2 minus 4 whole square. That's again 1 plus 36, that becomes root 37. We already got the answer. Just for clarification, let us check one more side. AC square root of, again by using the coordinates of A and coordinates of C, 7 minus 5 whole square plus minus 2 minus of minus 2 whole square, that is nothing but 0, 4 plus 0. Therefore square root of 4 means actually it is equal to 2. Okay. Now let us see. Here at least the side AB is root 37 and the side BC is root 37. Therefore two sides AB and BC are equal. Hence the triangle ABC is an isosceles triangle. Now another important application as a problem for we see, find the point in the x-axis which is equidistant from the given 2 points 2 comma minus 5 and minus 2 comma 9. It's a very interesting application actually. We know that a point on the x-axis is always of the form x comma 0 because there is no y coordinate, only x coordinate is there. Normally we denote that point as x comma 0. So if you are able to identify what is that x, you will get that particular point, and after that we will see how it is equidistant from these 2 points. So the given condition is this point, if I denote it as P, whose coordinates are x comma 0, is equidistant. Equidistant means the distances from the given 2 points must be equal from 2 comma minus 5 and B of minus 2 comma 9. That means we have to find out the distance between P and first coordinate. I denote it as A, it is missing, and second point I denote it as B. That means I have to find what is AP and what is BP. If these two distances are equal, then actually it is given as equal. In that case, we have to see what is the coordinate of that point. That's the way actually we are writing. Therefore, it is given as distances are equal because if this point is equidistant, therefore I can take it as AP is equal to BP. So if we take the square, AP square is equal to BP square. That means AP distance, by applying the distance formula using the coordinates of A and P, we can write it as x minus 2 whole square plus 0 minus of minus 5 whole square. That is nothing but x minus of minus 2 whole square plus 0 minus 9 whole square. That is x minus 2 whole square plus 25 is equal to x minus 2 whole square plus 81. Expand both the sides, we will get x square minus 4x plus 4 just by using a minus b whole square formula. That is a square minus 2ab plus b square plus 25. Similarly, this side also again that one plus is missing actually. It is actually x plus 2. X square plus 4x plus 4 plus 81. Now if you simplify, x square terms gets cancelled, 4 gets cancelled, minus 4x actually it is minus 4x plus 4x. It comes on the left hand side, it becomes minus 8x. Therefore minus 8x is equal to 56. Therefore x is equal to minus 56 by 8 minus 7. Some small print mistake is there, you please carry out. Hence the point P of minus 7 comma 0, where x is equal to minus 7 we identify, this is equidistant from the given 2 points 2 comma minus 5 and minus 2 comma 9. As you can check that if you find the distance AP, applying the formula by using the coordinates of A and P, root of minus 7 minus 2 whole square plus 0 comma minus of minus 5 whole square, that becomes root of 9 square plus 5 square. 9 square is 81, 5 square means 25. Then if you add these two things, you will get square root of 106. And BP is equal to root of 7 minus of minus 2 whole square plus 0 comma minus 9 whole square, that is 5 square plus minus 9 whole square, which is again root of 106. Therefore, AB is equal to BP. That means our given point with the coordinates minus 7 comma 0 is equidistant from the given 2 points. These are the problems actually students can solve by using different techniques. Now I would like to use some exercises for them. All the applications apply the same distance formula, and I have given the answers also for checking the results. Let them try and find out the answer. First question is, find a relation between x and y such that the point xy is equidistant from the points 3 comma 6 and minus 3 comma 5. That means they have to find out the relation between x and y by using the equidistant technique. In fact, the relation is given by, I have given the answer also. Let them check. The relation is 3x plus y minus 5 is equal to 0. Let them check it by solving this problem. Second problem, name the type of the quadrilateral formed if 4 comma 5, 7 comma 6, 4 comma 3 and 1 comma 2 are its vertices, and give reasons for your answers. So once we take these 4 points, let them identify the length and apply the properties. In fact, the quadrilateral, what they are going to get, it is a parallelogram. One very important property of parallelogram, they have to recollect it. What is that? Let them check it and find out the answer for that. And another problem is, find the value of A if the distance between the points A is equal to minus 3 comma minus 14 and B is equal to A comma minus 5 is 9 units. That means the distance between the given 2 points is given. Only thing is they have to identify point A. Again, by applying the distance formula, they can find out the value of A as minus 3. Let them check it. These are all some interesting formulas and interesting applications for the distance formula, so that students will understand and enjoy all this.
Sir, I've got a question here.
Yes,
there's one student whose name is Ujjwal Srivastava, and he's approaching us from Prayagraj, Allahabad, and he wants to know that how can you please tell us the simplest way of calculating. He has written, how can we find area of a rhombus if when all the vertices are given?
In fact, it is there. Actually, I kept it for the next part of this one. Now, for the time being, we will keep only the distance between 2 points. It is there. It will come in the next part.
So, Ujjwal, it will be there for you, but in the next session, in the follow-up session,
because in the next session, we are trying to find the area of a triangle.
Our students are very smart, sir. They are heading away forward than
yes,
we are
that's
going.
True, that's
so
true. No
that
problem.
is why I guess they
Teachers will always
but we can
them.
surely, sir, take up in the next session, I guess.
Yes, that's. I don't know who anybody who is taking, they will find out the answer.
Yes,
No
of
problem.
course.
One last portion I would like to discuss, because of the lack of time, I may not be able to prove this result. I just wanted to mention it. We call this as section formula. Suppose if we have 2 points, and if you draw a line joining these 2 points, then if you are able to identify any one point in between them, where the point actually exactly divides that line. In that case, how to identify the coordinates of that point? And that formula which gives the coordinate of that point, we call it as section formula. So that is given by like this. Consider any 2 points, A of x1 comma y1 and B of x2 comma y2, and assume that there is a point P, x comma y, is a point dividing AB internally. That means this point P is actually lies between A and B. That's the condition they have given. And in that case, we are getting 2 lengths. One is called AP, another one is called PB, and the ratio of those lengths actually given as M1 is to M2. That is PA by PB is equal to M1 divided by M2. If this is the case, how to identify the coordinates of that point P of xy? In fact, this is one of the very important application in the engineering. Some position, if you identify between 2 situations, how to identify the exact location of that point? That can be identified this wonderful formula, what we call it as section formula. In that case, the x coordinate can be identified because x1, x2 is known, m1 and m2 is known. Therefore, I can find the x coordinate as by using the formula m1 x2 plus m2 x1 divided by m1 plus m2. Similarly, y1, y2 we know and m1, m2 we know, and therefore the y coordinate can be identified as m1 y2 plus m2 y1 divided by m1 plus m2. In fact, the point P of x comma y is denoting by like this: x coordinate as m1 x2 plus m2 x1 by m1 plus m2, y coordinate as m1 y2 plus m2 y1 divided by m1 plus m2. This particular formula, which gives the coordinates of the point lies between the given 2 points on the line, we call it as section formula. Interestingly, if this point is exactly in the middle of the AB, then in that case the ratio is almost equal. Both the sides are equal. In general, we can take that ratio as 1:1. Therefore, if P is a midpoint of AB and it divides AB internally with the ratio 1:1, then we can see that formula by putting m1 is equal to 1 and m2 is equal to 1. We will see that the coordinate of that point is simply given as x1 plus x2 divided by 2 and y1 plus y2 divided by 2. I think we are not in a position to prove this formula. It needs little time. I just stated this formula. In the next session, they will see how to prove this formula and what are the interesting application of this formula, and in general, how to find the area of a triangle. As our one of the student asked, how to find the area by using this distance formula. First, by identifying the area of a triangle by observing the coordinates of the vertices. We will see the other areas of different geometrical figure in the next section. I hope all these things will helpful for our students. If they want to contact me, my email ID is vspraem@gmail.com or vspraem@yahoo.co.in. With this, if any questions are there, I am ready to face it. Otherwise, thank you.
Yes, sir, sure. We can take the follow-up in the follow-up session, which whatever questions were coming,
Yes.
as you said, that
Yes.
it's the next part of the chapter. So it could be taken in the next follow-up session.
Yes, madam.
So
Absolutely.
that is all for today for maths class student who were studying chapter 7 coordinate geometry. And sir, we again really thank you because you time to time you come for our students and you provide so informative sessions to them. Thank you, sir.
Thank you. Thank you very much, madam. Thank you.
एंड टू आवर स्टूडेंट्स प्लीज डोंट गो एनीवेयर आवर व्यूअर्स, क्योंकि अगला जो सेशन आप लोगों के लिए आने वाला है वो छोटे बच्चों के लिए, तीसरी कक्षा के बच्चों के लिए आएगा, जिसमें हम हिंदी की एक कहानी पढ़ेंगे और कहानी का जो शीर्षक रहेगा वो है कब आऊं। तो आप कहीं ना जाएं, बने रहें CIET NCERT के कार्यक्रम के साथ, लाइव इंटरेक्शन के साथ। अभी के लिए आपसे विदा लेती हूं। नमस्कार।
नमस्कार।